All right, so there's a bit to unpack here, but before we get started, I want to preface this whole thing with take it with a gigantic grain of salt. My methods are highly dubious and my data quality is abysmal, let's say, but it's an interesting thought experiment, so let's dive in. All right, so we'll start with the conclusion and then work backwards. So right now, at least May 2022, so just over a year ago, 13 months ago, America had 147 million employees-ish, 148 million. Now, based on the current capabilities of AI, this includes all machine automation, robotics, artificial intelligence, my estimate is that we could automate away almost 25 million jobs today. Now, that requires the deployment of new products and services. So those products and services do not exist yet, but the underpinning technology does, which means that the only thing preventing us from getting that employment is just inertia. The time that it takes to develop the products and software, the time to get it approved, and the time to implement it and then make those changes. So as of right now, almost 25 million jobs are vulnerable to AI with the capabilities of GPT 3.5 Turbo and GPT 4. And then, of course, all the other open source and commercial competitors that are near peer adversaries. Now, that being said, if you look at the jobs that, based on a job's intrinsic requirement for humans, basically, you look at the kinds of jobs that you're going to pay to have a person doing, regardless of what the AI is capable of. These are the jobs that are going to be vulnerable just by virtue of the fact that you don't really necessarily need a human doing it. The numbers become a little bit scarier. And my estimate, this is worst case scenario, is that in the near future, 77 million jobs out of the 147 million jobs are vulnerable to being automated away. Basically, this calculation is a rough estimate on market demand. How much do you actually want a human doing that particular job? Which means that in the worst case scenario, we go from 148 million employed to 70 million employed. That is more than 50% lost. So I have been repeatedly saying, we could face 70% unemployment, 80, and other people say 80% unemployment. Here's the numbers to back it up. All right, now, since I got your attention, let me tell you how I did this. And again, remember, this is incredibly dubious, so take it with a huge grain of salt. But basically what I did was I took the GPT-4 0613 model, and I gave it instructions. I said, you are a BLS chatbot, and you're trying to assess the risk of having jobs automated away. Yada, yada, yada. The TLDR is that I asked it to judge jobs or occupations based on job activities. And I had it break it down into percentages based on 3 categories. So the first category is dexterity. So this is high friction in physical space that requires compliance, manual dexterity, kinetic intelligence, that sort of stuff. Because yes, we do have a few robots that can do this, but there are, as of right now, no general purpose robots that are capable of operating anywhere near human level in terms of dexterity. There are no general purpose surgical robots. There are no general purpose labor robots. Just doesn't exist. Now, that being said, you can robotically automate like a skid steer or a tractor or something. That's fine. That's not what I'm talking about. I'm talking about what a human can do with your hands and body. And then the second category is solo work. So this is work that can be done in front of a computer or otherwise electronically by yourself. On your phone, on a computer, that sort of thing. And then the third category of job activities is group stuff. So this is communication, collaboration, face-to-face time with other humans. And so those 3 categories break down and kind of judge that's part of what I use to judge the vulnerability of a job. So if it has low dexterity, it is at much greater risk of being automated away just with today's technology. If it is mostly solo work, it is much higher risk of being automated away. And if it's a high group activity, then it's a much lower risk, because that indicates that the human connection component is a big part of it. And then finally, the vulnerability score is a standalone score, which is used to basically assess how much you want a human doing that job. What is the intrinsic need for that job? And if the number is lower, if that means it's less vulnerable, which means you're more likely to really want to have a human in that job and you're willing to pay for that. Whereas if it's a high vulnerability score, then that means that there's no intrinsic economic or personal or whatever, there's no intrinsic demand to have a human in that job. If you could automate it away, then you might as well. And so this is like machine shop workers, right? You don't need a whole heck of a lot of empathy or communication skills. And I can hear all the machinists saying, yeah, like hell. Because machinists actually do have to do a tremendous amount of communication. That being said, the actual hands-on machine stuff, that part could be automated away. If, of course, the machines become more dexterous, right? Because dexterity is a huge component of that. So that's why I broke it down into these 4 categories of vulnerability. And I had ChatGPT just kind of do these rough estimates. And it did a pretty good job using GPT-4. So I downloaded the data from BLS, and I excluded the detail and broad ones because they're very, very highly specific. And I noticed that it was like, okay, the job duties really didn't change. So I only focused on the minor and major categories, which ended up being, let's see, that was 116 categories. So that's still 116 categories that it was used to estimate in terms of vulnerability. And I've got it all color-coded, so I'll tell you how to interpret the data in a second. Here's the thing. So the first thing, sorry, good grief, I'm going too fast. Here's the repository. The first step of this is to break it down. It's very, very simple. You open the data, this CSV data, pipe it in, you get the result, it pipes it back out in JSON, and I can show you an example of the debug here. So it captures everything, occupation code, description, and employment. So that's what it gives it so that it understands. And of course, ChatGPT already knows what all the occupation codes actually mean because it's baked into the training data. And so if you go and talk to like ChatGPT and say like, hey, what does BLS occupation code 17-1000 mean? Give me some examples, and it can give you a good explanation. Now, one thing that I had it do was to, in the output, it actually tells me why it made the judgments that it did. So this is where explainability comes in. So here's an example of the final output for code 41-3000, sales representatives and services. Total current employment is 2.1 million. Dexterity, rather low. You got to call some people. A significant portion of their work can be done solo on a computer, such as managing customer databases and orders, which make it susceptible to automation. However, a large part of their job, about 60%, involves group collaboration and communication, such as face-to-face meetings and negotiations, which is difficult to automate. The intrinsic technological vulnerability is estimated at 40%. So it's a relatively low vulnerability job because, yes, there are some things that you can automate away, but in general, you want to be talking to a human sales rep to close the deal. So in this case, the numbers kind of all come together to say, okay, let's see. This estimated that we might lose about 26,000 jobs, 255,000 jobs, leaving 1.86 million instead of the 2.1 million. Because again, if you can automate away a third or a quarter or a half of a job, that reduces the demand for people doing that. And if you have tools that can accelerate it and make it easier, then of course you have less demand for someone in that role. Now, that being said, this vulnerability score means that in general, you still want to have a human there, even if you have less demand for humans overall, aggregate demand. So think of it in terms of aggregates. Okay, so That is how I achieved that. And let's see, I kind of lost my train of thought. Okay, I guess we can go over the code. It's all pretty straightforward. I've got it documented. It dumps it all out into the YAML files here, so you can look at all, however many there are. 116, so you can look at the reasoning that it used for each one, and you can monkey around with this if you want. You can rerun it. All the code is there to regenerate this data. But then I got it all into this. And so this is the total data, and I've got it color-coded. So I have total number of jobs lost, and this is color-coded so that the higher the number, the darker or the more red it is. And of course, it's not proportionate, so I added a percentage lost. And so this column here, the jobs lost and percentage lost, this is most likely based on some really rough numbers based on what I know AI is capable of today. And so remember, here's my credibility. I was an IT automation engineer. I've deployed servers and software and cloud and everything to automate and support businesses. And I've integrated all these systems. I know what it takes to run these systems and to do the job of like a DBA and business analyst and financial comptroller. I talked to everyone when I was in a corporate job. So that being said, remember, like, I'm basically throwing wet spaghetti at the wall. So this is a educated guess as to percentage of jobs that could be automated away. Obviously, I'm less familiar with blue-collar jobs, with manual labor jobs. I have done them in the past. I've worked nights in stores and warehouses, so I kind of have a feel for that. That being said, I have poured concrete, but not professionally. So, take some of that with a grain of salt. Now, percent loss, you see some of the higher ones, computer and mathematical operations. Okay, yeah, that makes sense. Stuff with a low percentage loss, occupational therapy and physical therapists, assistants and aides. This is at a very, very, very low risk of being automated away because it is, one, it's a highly dexterous job, and you also very much want a human. I've dated a physical therapist before, and it is an intensely emotional job, and it has to do with communication, verbal and nonverbal communication. There's a tremendous amount of human connection involved in that. So I totally agree with the result here where, health support and stuff. So all these numbers are jobs that are at very, very low vulnerability for being automated away. And then you see, oh, wait, here's a big chunk here. So communications, clerks, information handling, material recording, secretaries, other office and admin, all at very high risk of getting automated away. Because again, these are things that you primarily do in front of a computer. Agricultural workers, this is 8.5%. Because again, some of it will be automated away. And you see most of them are around kind of like the 10 to 12% range. With a few categories being much, much more vulnerable to automation. Now, that being said, there is, I have a second sheet, and in this second sheet, what I did was I removed all the major categories. So you see, like, it's 11-1000, 11-2000, so I removed 11-000 so that we would have a finer grain view to look at the total data for each of the minor categories. And so here, it's the same pattern. Obviously, I just removed some of the stuff so that we'd have more accurate in terms of total numbers. Now, what I did was I estimated total jobs lost that could be automated away right now. So that's right here. So that's how I arrived at that data. Is okay, based on all these vulnerabilities, scores, and stuff. What is the maximum jobs lost that we could anticipate here? And then, of course, you just take that away from, total remaining, et cetera, et cetera. Simple arithmetic. Now, over here, I said, okay, let's ignore what AI and robotics are capable of today, and let's just look at the aggregate demand for humans in a particular job. And so, for instance, in computer occupations, there's not really a strong need to have humans doing that to do most of those jobs. If the computer works, nobody cares. As an example, and as a former IT specialist, I can tell you that my humanity didn't really matter. It was as long as the lights were on and the registers were running, nobody cares. Drafters, engineering techs, a little bit less demand. Let's see. There's some, yeah. So what are these? Communications operators, clerks. These are at super high risk. Agricultural workers. So this is one of the ones that's kind of a paradox, because on the one hand, right now it's at a very low risk because it requires a tremendous amount of dexterity. But as long as the food gets on the table, it doesn't matter who put it there. So in terms of intrinsic vulnerability, it is a very high intrinsic vulnerability. So that's why I've got all these color coded here. Let's see. Yep, so that's that. And so what I used there was to say, like, what is the maximum possible attrition we could see based on, okay, if we can get rid of 20% of executives, that's basically what this means, is that the aggregate demand for executives, for top executives, goes down by 20% because we can automate away a lot of it and make things easier and faster and so on and so forth. So that means we could have an attrition of 700,000 executives, leaving us with 2.9 million executives. But then you go down, and because this is imagining the future where it's like, okay, let's take the farm workers, the agricultural workers, for example. And so right now we have, looks like we've got a total employment of 390,000. But there's only so much demand for that. So imagine we put AI in every John Deere tractor, every combine, every hopper system, and you basically have entire farms with no humans. That's what this 0.85 means. So we'd have an attrition rate of 85%, leaving only 58,000 farmers in America total. Now, of course, this does not include seasonal labor, so that's slightly different. Construction workers, this is another example where it's kind of a mixed bag. So the attrition rate here would be expected to be about 40%. But then again, like, this is a super highly dexterous thing with that is primarily collaborative work. So this is going to be a very, very difficult one to automate away because it's very high risks. If a robot makes a mistake, an I-beam gets dropped on someone and they get killed, right? And so you'll probably have a threshold where it'll be safer and cheaper to just take humans off the job site entirely. Now, that being said, we are already seeing that a little bit with like the 3D printing home printers, where it's like a robotic gantry that just sits over there. It's got its pile of material and it just builds the house with no humans involved at all. And so that's what we have to look out for, is that in some of these cases, there's going to be this saltatory leap where it goes from 4.5 million employees to 0 very quickly, because as these new technologies rolled out, you're going to replace them all wholesale. Some things are not going to lend themselves to being gradualistically replaced. Truckers are going to be the same thing. Once we figure out how to automate truck driving, it's just not going to make sense to have truck drivers. Now, that being said, that's a very high threshold, but once you reach that threshold, it's a step change. So that's what I mean by saltatory leaps. It's a step change is a more common term versus gradualistic, where you kind of replace people slowly. In some cases where you replace people slowly, that could be like IT staff, right? As a former automation engineer, I can tell you that I have personally reduced headcount in infrastructure departments by automating away jobs, which reduce the demand. But it was over time, right? It was like, okay, well, we can do more with less. Let me automate a little bit more, and then we can do more with less, and so on and so forth. And then eventually it was basically just me running the whole department by myself as an automation engineer. Not everything lends itself to that. But that being said, the amount of logic that goes into making decisions, even financial decisions or executive decisions or HR decisions, a lot of this is now within the realm of possibility of GPT technologies. So when I say that we could get rid of almost 25 million jobs right now, that's a number that I will stand behind. Again, it's going to take time because there's inertia. But then in terms of total risk of jobs that might go away for good, looking at 77 million jobs in America, leaving us with only 70 million jobs. And we have a population of what, 350 million or 400 million right now? So that's an employment rate that is very, very low. That's a very high unemployment rate if that comes to pass. And again, some of these things are dependent upon robotic advancements that are actively being worked on. construction robots, surgical robots, general purpose domestic robots. So that the aggregate demand for human labor is going to fall off a freaking cliff. That being said, like, okay, what happens when you have 70 million people, which is less than a third of the Americans out there? Let's see, what is it? I don't remember the population, but let's say we have 380 million Americans right now, and we end up with only 70 million jobs. Oh wait, where's the invert? There we go. So that is that is only 18% of our current employment. So that means we'd be having an unemployment rate of about 82%. Yeah. So we go if we end up with an unemployment rate of 82%, that is not good. Based on current paradigms. And so when people say, oh, well, Dave, you keep advocating for universal basic income and that's socialism. Well, if only 1 out of 5 people have a job, we got to do something, right? It's that simple. Now, one thing that I wanted to point out is that people are like, well, where's the money going to come from? Well, where does money already come from? Money is created through minting money and giving loans to central banks. And who do the central banks give money to? They lend it out to other banks and corporations. That's where money comes down from. It doesn't come from the bottom up. Money is created at the center of the economic system, and then it percolates outwards. So when I mentioned in another video recently that B2B transactions are going to be what drives the economy, that's what I'm referring to. Because, if a company lends money to another company or bank or whatever, and then they have goods and products and services, the aggregate consumer demand is only part of that equation. Because if you have a lights out company that's selling goods and services to another lights out company, the economy is going to be red hot, even though there's no humans involved. So that's why I mentioned in my post-labor economics video that we're going to need new KPI. And we're also going to need to redistribute that, because right now, the only way that money gets into the hands of consumers is through either the very few entitlement programs that we do have, which are relatively weak, or through employment, through money coming by force of extraction downwards through the grapevine from the central banks to the regional banks to the corporations, and then finally to us. But if we reverse that, if instead, so this is basically what universal basic income is to me. If instead of lending money from the Federal Reserve to the central banks to the regional banks, what if we instead take about half of that and just give it, instead of lending it out to banks, we just give it to consumers? And you just flip the system on its head. And so then the total amount of economic change is pretty much identical. You're not printing any more money than you already were. Anyways, this is all getting very abstract. Point is, there's a lot of change coming, and here's some numbers to back it up. Thanks for watching.